Hi, welcome back to the channel. In this lesson, we'll see how to convert the sector of a circle to a cone. We'll calculate the radius of the base of that cone. I'll be glad you pause this video, take a look at the question, then come back to see my solution with necessary mistakes students make when solving this problem. That said, let's get into class. Hi, welcome back. The question says the sector of a circle of radius 4 centimeters contain an angle of 60 degrees. The first thing I want to do is to draw the sector. Now, here's a circle, and here's the center of the circle, and here's the radius. So that this portion here is referred to as the sector of a circle. The first common mistake I see students make is not understanding what is actually called the sector of a circle. Now, here is the sector of this circle, and we've been told it has an angle of 60 degrees. So the angle in here is 60 degrees. Now, the second mistake students make is not drawing this diagram. They try to solve this problem without drawing the diagram. That way, they cannot efficiate the problem. Now, if this sector has 60 degrees and is folded to form a cone, that is, this sector, here's a sector, and it has how many degrees? 60 degrees. It's now folded to form a cone. When it's folded, it's going to form this cone. Permit my diagram. Now, if it's folded to form this cone, we're expected to calculate the radius of the base of the cone. Now, here's the base of the cone. That is this circle at the base. Now, we have to calculate this radius here, which is what? Which is r. Now, if you look at this sector that is being folded to form this cone, they will have a point of similarity. And the point of similarity here is the base of this sector, or the arc here, the arc of this sector is going to translate to the base of the cone. The first thing is, what is the formula for the arc of this sector? Now, let's call this the radius of this sector. Let's call it big R. So that the formula for the arc of this sector here is given as, that is this arc here, is given as, that the arc is given as theta over 360 times 2 pi r. That's the big R. I've classified this as the big R. Now, while the length of this circle here, that is the circumference, is given as 2 pi r. Now, we note that the arc, the length of this arc, the length of arc of the sector is equals to the circumference of the cone. So that we're saying that theta over 360 times 2 pi r is equals to 2 pi r. Now, I'll divide both sides by 2 pi, since I can see 2 pi in common. This 2 pi, I'll divide this side also by 2 pi, this 2 pi, so that the r I'm looking for, theta over 360 times big R, is equals to r. Now, my r will now be equals to, theta is 60 over 360 times the big R, that's 14. Here is 14. So 60 here is 1, 60 in 360 is 6. Obviously, R is equals to 14 over 6. 2 here is 3, 2 here is 7, which is equals to 7 over 3. Then R obviously is equals to 2.33 centimeters. Now, that's the value of R. With this, I hope you've seen common mistakes students make and also how to solve this unique problem. Thank you for staying with us, and see you in our next class.